You are welcome. This is our first lesson under current electricity, A-level physics, prepared by Joseph Mayanja. In this video, or in this lesson, we are going to explore what is current electricity, how many types of electricity you expect, and later we are going to understand electricity in general under A-level physics. Before we go any further, there are some basic questions we have to ask ourselves. What is electricity? Very many occasions at home, when you have a blackout, you always hear people say power has gone off, electricity has gone off. What is electricity? The second question we are going to answer is, what is current? What is electric current? And that is why we are here. So stay put and let us get started. Whenever electricity, or whenever you have a blackout, you always hear people say, or your sister, or your brother, or your dad, power has gone off. So to clear everything, electricity simply means the flow of electrical power or charge. Whenever there is flow of charge, we expect electricity. We must understand that electricity is just another type of energy, and it can be built up in one place and then it can flow from one place to another. In your country, electricity is generated from a certain dam, or depending on where they generate electricity from, and then it is moved to another point or to another place. That is basically electricity. When electricity gathers in one place and it is static, it is not moving, that one is termed as static electricity. And we are going to study static electricity in a chapter called electrostatics at A-level physics. So we are emphasizing that the word static simply means something that does not move. So when it comes to studying electricity or static charge or static power, then the study of that science is what we call electrostatics. But in this lesson, we are interested in electricity that is actually flowing, and that is what we call current electricity. And we are saying electricity that moves from one place to another is just what we call current electricity. We are saying electricity is a flow of charged particles, which may be electrons or ions. We know that all conductors have what we call atoms, and then in the atoms, when you look at the structure of an atom, atoms are made out of electrons, ions that are negatively charged, those are what we call electrons. Then we have the protons that are positively charged and the neutrons that are neutral. All atoms have those electrons, what we call the negatively charged ions. The moment those charged particles flow from one place to another, then we are having electricity. So all the time when you hear people saying electricity has gone off, simply it means that there is no more flow of electrons. The flow of electrons or the flow of charge is cut off. Therefore, that is why in most cases you have what we call a power shutdown, or a blackout, or a road shed, like many of you call it. We have types of electricity, and the types range from where that electricity or the nature of that electricity. We have current electricity, and we are saying this current electricity is electricity that flows from one point to another. And then we have what we call static electricity. Static electricity is just electricity where the charges are static, they are never moving. And then the study of that we said we are going to call it electrostatics. And then we have solar electricity. This is electricity that is harnessed from the sun as our source. And then we have hydroelectricity, electricity that is harnessed from water. And in most countries, you hear people using dams, turbines, and all that. All they are trying to do is to harness this electricity, what you call the hydroelectricity power. What is current? You are saying current, like we have emphasized that whenever you have electricity flowing, then we have what we call electric current. So to define current, or to define electric current, we are saying it is defined as the rate. We must emphasize the word, the rate of flow of charge around a circuit. In other words, if you have an open circuit, we don't expect current to flow, or we don't expect current in that circuit the moment the circuit is open. So we only have current flowing, electric current flowing in the circuit when it is a closed circuit. Then if Q represents the quantity of charge passing through a point any time t in seconds, then the current represented by I is always given by the expression I is equal to Q over T, simply meaning that we are saying current, Q standing for charge and then T standing for time. Every time you define something and you hear someone say this is a rate of flow, whenever you hear the word rate, it means that they are trying to emphasize the idea of time. So in this case, current is defined the rate at which the charge flows from one point to another in the circuit, and that is what we call current. And we are emphasizing that flow of electric current happens when there is a closed circuit, and later we are going to emphasize, or from your ordinary level physics, you know how a complete circuit looks like. But don't worry, at this point still we are going to look at how a circuit looks like for sure. The SI unit of current is what we call the ampere, and it is denoted by letter A, capital A, uppercase A. The study of current, or the flow of charge in a circuit, was done way back in the 80s. Around 1836, there is a man called Andreas Ampères. He's the one that made discoveries and discovered that whenever you have two current carrying conductors, they experience a force. And from that study, he defined what an ampere is, and we are going to see what an ampere is. So we are saying the SI unit of current is an ampere. The instrument used to measure current is what we call the ammeter. And in very many practical classes, when you visit the physics lab, you see something like this. And usually when you look at it critically, it has 3 terminals. But all the time you want to use it, you have to connect to this terminal, and then you also either connect to this terminal or to this terminal. But when you connect to this terminal here, it means that you are using this scale here, the scale that runs from 0 to 1 ampere here. I think you can see there are 2 scales. There is that one that runs from 0, 0.2, 0.4, 0.6, 0.8, then 1. Then there is another scale that runs from 0 to 5. That is if you connect to this terminal 1, and then you connect to terminal 3 here in the circuit. And later we are going to emphasize that usually an ammeter is connected in series, because the importance or the work of an ammeter is to measure current that flows in the circuit. So if you want the ammeter to measure the current that flows in the circuit, you always have to connect it in series with the source of current. That takes us to the definition of an ampere. Andreas Ampère emphasizes that if you have 2 straight parallel wires of infinite length placed 1 meter apart in a vacuum, and we are saying that scientifically whenever they talk of a vacuum, it means that they are talking about a place where there are no air molecules. We are saying these wires are carrying current. It can be either in opposite direction or in the same direction. These two experience, or they will produce a force. Andreas Ampère suggests that whenever you have 2 straight parallel wires of infinite length pressed 1 meter in a vacuum, and then they experience a force F of 2 exponent negative 7 newtons per meter, then the current flowing is actually 1 ampere. That is what Andreas was trying to say, that whenever you have 2 wires, straight wires of infinite length, and they are placed 1 meter apart in the vacuum, and they experience, the moment they experience a force of 2 exponent negative 7 newtons per meter, then the current flowing is actually 1 ampere. We must emphasize that the SI unit of charge is what we call a coulomb? They are saying a coulomb is the quantity of electricity which passes any point in a circuit in 1 second when a steady current of 1 ampere is flowing. Remember, we said that current is the rate of flow of charge. Now, that implies that Q is actually I times T. So if one wants you to define what a coulomb is, it means that you must tell us that this is the quantity of charge. Quantity of charge, because a coulomb is a sign of charge. So we are saying this is a quantity of charge which it passes any point in a circuit in 1 second when a steady current of 1 ampere flows. And that is what a coulomb is. Let us try out this problem. So in this problem, we are given a charge of 20k coulomb. That one simply means that the charge is 20,000 coulombs, crosses 2 sections of the conductor in 1 minute. They have also given the time of flow, that is 1 minute. How many seconds are in 1 minute? Those are 60 seconds. Then they want you to find the current through the conductor. We know that current is just the rate of flow of charge. So from that expression, we can happily find the value of I, which is the current. So if we do the substitution here, we just say 20,000 coulombs divided by 60 seconds. And basically that becomes 20,000 divided by 60. You get 333.3 amperes. That one takes us to another common terminology. This terminology is not new to you, and the terminology is potential difference. So the question is, what is potential difference? Potential difference, PD, I must emphasize that PD is a standard short form of potential difference. It's defined as the work done in moving 1 coulomb of charge from one point to another across a conductor. So the idea is that if this is your conductor and this conductor is in the closed circuit, as the electrons flow, because we know that whenever there is current flowing through this conductor, it means that there are some electrons that are flowing. So as these electrons flow, they encounter some opposition to their flow, and that is what we term as resistance. So as they flow and as they overcome this resistance, they are doing some work against that resistance, and that work is what we are terming PD, and its symbol is V. So we are saying PD is just the work done in moving 1 coulomb of charge from one point to another across a conductor in a closed circuit. We must emphasize that current will flow through a conductor if there is a potential difference between the ends of the conductor. For example, if the potential at this point here is 0 volts and then the potential here is 3 volts, then there will be flow of current, because there is a difference in potential. Here the difference in potential is actually 3 volts minus 0 volts, and that will be 3 volts. That's the potential difference. So for always current flow through a conductor, there should be a difference in potential between the ends of the conductor. The SI units of PD is a volt, and later we are also going to define what a volt is. PD is measured by an instrument called a voltmeter. A voltmeter looks exactly like an ammeter, but the difference is that with the voltmeter you will see a V here, and it also has 2 scales. You have the 3-volt scale and the 5-volt scale. So when you connect the terminals here and here, then you are reading, you are interested in this scale here. This is what you call the 3-volt scale around here. Then you also have the 5-volt scale from here up to here, the upper scale. And in the circuit, the voltmeter is connected in parallel with the load whose PD is under investigation. So when you are connecting a voltmeter, you cannot connect it in series with a current source, because in the construction of a voltmeter, it is made to have a very high resistance such that little current can flow through it, because its work is to measure the work done by a coulomb of charge across the ends of the conductor. So if in your circuit, let us assume this is the circuit, and then you have a battery, a cell, then you have an ammeter here. This is our cell, and then this is our resistor. A voltmeter is connected across this. Because if you want to study the work done by a coulomb of charge to move from one point, from this point A to this point B, then you connect a voltmeter across it. You cannot connect it in series. So this will be the voltmeter to measure the PD across that area. Then the ammeter is connected in series with the power source, because its job is to measure the current. Can we define what a volt is? Because we are saying PD is measured in volts, or the SI unit of PD is a volt. So we are saying a volt is the potential difference between 2 points when 1 joule of work is done in transferring 1 coulomb of charge from one point to another. Basically, that is how you define a volt. So this is how a basic circuit looks like. Later in the chapter, you are going to see many of these. This is what the symbol of an ammeter. So when you see a circle with an A, that one becomes an ammeter. Then this one is a symbol of a cell. If you have a circuit having many of these, you have something like this. Combination of more than one cell, that one becomes a battery. Now that is a battery. Then symbol for a switch in any circuit. You are to have a voltmeter in this circuit, and a voltmeter can be connected across this external load or the resistor. This is a symbol for a resistor. Then this is a voltmeter. That is how a basic circuit looks like. And in most circuits, you are always going to find something like that. Sometimes you can also have a rheostat. You have something like this in a circuit, then this one becomes a rheostat, what you call a variable resistor. And it is usually used to either vary or increase or reduce the current flowing into the circuit by either increasing the resistance or reducing the resistance. This one is just a standard resistor.